So I'm going to jump right in talking about laboratory automation and who the heck we are and what we do as well. So a little bit about myself. So my name is Khaled. We're a company and we're located up here in Canada, just outside Toronto. I did my master's in mechanical engineering, and my main thesis was around material development. So we were working on new adhesives actually for the automotive industry. And what we found, or what I found at least, is I sat in a lab doing a lot of testing and a lot of characterization of different compounds. And so it was very manual testing. And I really hated it after a while. But I also realized that making materials is a really difficult, long process, whatever material you're making. And so we started a company around that thesis, which is that if we can improve the way that materials are made and speed up that process, we can really help to change the world in a better way. And so that's the main reason that we started the company. We started it about 6 years ago, just to give everyone a bit of a reference. So in terms of agenda, we'll talk a little bit about Labscubed, what we've built, and some research behind what we've done to date. Then we'll talk a little bit more about what is automation and AI for labs, what is it, how does it work? And I know you guys will hear a little bit more on the data side and the software side from Uncountable. We have a great platform. And then lastly, we'll talk about how to prepare your lab for Industry 4.0, that concept around full automation, and this really cool thing called a map, which I'll kind of explain near the end as well. So a little bit about ourselves. We build actual hardware that goes into labs to automate testing. Specifically in the rubber industry, it's tensile testing, tear testing. And our goal is very simple. It's to make really easy to use, affordable testing in a box. So you don't have to kind of retrain your team. You don't have to change the way you do anything. These systems that we've built are literally plug and play. You place them on a table, you plug them in. It takes about 15 minutes to train a technician. And then from that point on, every one of your technicians will get great data every single time. And we have this hardware. So the easiest to do here to show you a quick video. I know it's a bit jumpy because of the way videos work on here, but essentially with our machine, you can put in tensile tear samples, ISO, ASTM, JIS samples into a tray, put the tray into the machine, press start, and then it'll automatically load each sample, test each sample. We have really sophisticated vision systems and sensors to kind of collect a lot of data and metadata, which is really important for future development, for future work that will be done with that data. And essentially you pull, you break, the same thing that your technicians are doing every day, we're just automating it and making it really attainable for everyone in every lab. In terms of the hardware itself, automated tensile tear testing, like I said, ASTM, ISO, calibrated and certified those standards. We have customers that have extremely high accredited labs, like Bridgestone, for example, is one of our customers, Airboss. They're using it both production and R&D side of things. So we are fully certified. The product has been out there for over 2 years now, running it full, some customers running it for 3 shifts a day. We have kind of a lineup for machines. So we have a smaller machine that's able to do less samples, really for R&D, where you're trying to get really high consistency, but your volume isn't as much of an issue, but automation still has that benefit. And then for somewhere, automation, the benefit really is that they need to just run through as many samples as possible from a production point of view. So it's really easy, really fast to use. We use video for a whole bunch of things. I mean, most people today can still use video for elongation, but we use it to actually analyze good or bad breaks, coloration, a whole bunch of other things as well. So I think one of the most important things when you think about automation in a lab is how does it actually improve consistency or the data output that gets created? So we've done a really large consistency study and we continue to do it with customers. Every single time new customers come along, we kind of do this. So we do it by trying to control as many variables as possible. So we run control samples that we create, that we have. We randomize the sample selection. So once we stamp out, let's say, a whole bunch of samples from a huge sheet of rubber, we randomize that so nobody's getting like certain batches. We cut out the samples, we measure the thickness, we measure the width, and then send out these materials to different companies, and they run both on their manual system, so their technicians actually running on a conventional tensile machine, and then we run an automated fashion and we do a comparison to show that consistency potential increase that should exist. We've run thousands of samples doing this, so it's quite a large study that we've done across the board. And essentially what we found is, as you would guess, consistency and your coefficient of variation gets better as you use automation versus manual. And we've seen this not just with tensile testing. We've also played around with customers who have like automated rheology systems and different systems that are also automated hardness. And it does exactly the same thing, plus or minus. And it's not a small increase. I mean, for most customers, we're finding around 40% is the average increase in consistency that you get in a batch, for example. And that can be really important from an R&D perspective. So you obviously want to make sure that when you're doing R&D, you're getting the best data and you're doing it quickly and you don't have to test a ton of samples. You can test less samples and still get really accurate data. And from production, it's really important because it can start to tell you when there's issues earlier because you know that your coefficient of variation is very low when you use automation. And so anytime that kind of starts to get away from that, you can kind of find those issues earlier. So this consistency results can be really important across the board. In terms of accuracy, we've done accuracy studies as well. Obviously, once you introduce a new product and a new machine and a slightly different way of doing things, people want to know, is it accurate? We participated in a study where it was, over 100 labs. They get sent out samples from the centralized system, and the samples are then tested by all of us autonomously. We don't know what the data is. We send the data back in, and then they show us this graph at the end to show where we're at. So you can see for the left-hand side, our stress pretty much bang on compared to the average of where all the labs are. Our strain's a bit higher, as you would expect, because we're using a vision extensometer and not a physical extensometer. So we're very accurate and yet that much more consistent than what exists out there. Benefits of automation generally is time saved, obviously. Your technicians are no longer sitting there doing that thing over and over. On average, we find it's about 85% of your technician time is saved. There's still some aspects to setting up samples and going through certain parts, but really the majority of what they do is no longer sitting there testing one at a time, as you probably see people doing all the time. Consistency is a big one. You're increasing up to 40% more consistent, which I think is a really big, very important point, especially when people start to consider wanting to use their data that they're producing in their labs for AI systems, for prediction capabilities in the future. And we'll kind of talk a little bit about this in a bit. That becomes really important. Oh, and then lastly, I think a couple of very interesting points we found as we go along. There's cleaning backlogs. So obviously customers now, they have technicians that have time, so they can clear out their backlogs, speed up the process when it comes to R&D, which I think is very important. A sales tool. So once you show that you're bringing in automation and new technology, your customers will see that. And I think there's usually a very positive sign that things are moving forward, that your company is moving forward. Last one is attracting young talent. I think that's really important to bring in. And I hear this all the time from everybody in the rubber industry that, it's a very difficult thing to attract young talent into our industry, into the rubber industry. It's not sexy enough, I guess. But I think this is the way you do it. You show them that we in the rubber industry are implementing new technologies. We're implementing the future, and that their future in the rubber industry means that they can actually use these tools that are important to them. So quickly about automation. I'm not going to talk about robotics and systems. I think we've all seen them. You'll see them in manufacturing. You see them everywhere. But the main thing I always ask people when they come to us to talk about automation in their labs is, do you have tasks that your employees are currently doing that are repetitive, that are a bottleneck, slowing things down, that have human error associated with them, that you have to retrain people? When you have to hire a new technician, it takes a really long time to train them to get really good data. If your answer is yes, then that's something you should be looking at automating in some way or another. Now, it might be that it's prohibitive, it's too expensive to automate. There's a whole bunch of different reasons not to do it, but it's still important to start looking out there and seeing what's out there, because one day someone comes along and creates something innovative that solves your problem. So I think that's kind of the main question that I always ask people. The other thing I want to say is not all tests can be automated. I've been in labs where there are tests that are really technician-driven, require a lot of knowledge, and are very difficult to automate. In those cases, those might be something really for the future, but that's the main question that I ask when I talk about automation with customers in terms of hardware itself. So talking about artificial intelligence is the other piece of it. Generally speaking, artificial intelligence systems are systems that predict algorithms. I think a lot of people kind of convolute and make AI really complicated. Everyone talks about it, but the best thing that anyone's ever described for me is that you replace the word AI with the word prediction, and it's pretty much what someone's trying to sell you. If they're trying to sell you an AI system, essentially they're telling you, I can predict things better than you can, faster than you can, in theory, using this software. The concept of AI was introduced a long time ago, back in the 1950s. So it really begs the question, kind of, why did it start in 1950 and only become so big today? And there's two reasons. Number one, today we have a huge amount of data that we're creating, clean data, good data that's actually digitized. I think that's another one. A lot of you will know from your own experiences or knowing from customers, a lot of data that they have that's historic is sitting in files, literally in folders, in shelves, or they're sitting as a scanned piece of paper or something, where it's really hard to kind of digitize it and read it. But today, all that data is kind of being digitized through our phones, through our laptops. You guys all create Excel sheets all the time. And so I think a lot of data, because it's really important to AI, is being created. The second thing is the cost of prediction has gone down. So every time you have to crunch through data, there's a cost to that. It used to be that you'd need to use supercomputers to do it, but today your phone does it, your laptop does it. So you put those two things together, lots of data, and it's really cheap to do stuff with it, and you get a whole bunch of AI in all parts of our lives. One quick example that I kind of usually try to get into, just to give an example, anytime you hear machine learning or neural networks or any of those other words, essentially they're all AI systems that are trying to predict things using different ways of doing it. One common one is supervised machine learning. So in this case, the example is you're giving the model pictures of apples and you're telling it it's apples. And then the model learns about all the apples in the world. And then one day you feed it a random picture of an apple and it should predict, hey, that's an apple. And that's a prediction model. And as you can see, it's very important that known good data goes in. If we fed it pictures of oranges and we told them those oranges are apples, it would predict incorrectly. So it's all about that good known data. And that's a big part of this, is clean, good data is the most important thing. If you feed really bad data into any model, I don't care how great it is, it's still going to give you a bad prediction. So the data and what you're producing is really important. Hence why as you automate, you get better, more consistent data that becomes, your model becomes much more powerful and much better at prediction. So clean data. Clean data is organized, is traceable in the same format, hopefully in a cloud-based system so you can do stuff with it in the future. And I think that's a really important part of it as well. So for example, if you're looking at an Excel sheet and numbers are randomly placed all over the Excel sheet and there's no headers and there's no information connecting anything, you wouldn't be able to make sense of it, and neither would a computer. So that's kind of how I think about it when I think of clean data, as the simplest way to kind of think about it. But that's why when you automate, again, in labs and you automate your production and your manufacturing, you're actually collecting really good, clean data that you're then able to use in the future to create really smart plants and labs. I'll give you a couple of examples because of the automation that we've implemented in our systems. And we collect a lot of data that you see, obviously, the stress strain curves, and we create a whole bunch of, the moduluses and all the normal information. But we also collect data on all the sensors, all the motors, how the cameras are recording, the discolorations that might occur in the samples. All that data is being collected and saved. And from that, we've played around a little bit. We were, for example, able to predict the hardness of samples. We don't have a durometer in the machine, but we're within 1% accuracy of predicting hardness of the samples that are run in our system because of all the great clean data that we collect. We can predict good and bad breaks. Before the sample breaks, we can actually tell within a 95% accuracy if it's a good or bad break. And that's getting better and better as the system keeps learning and learning. So there's endless things you can do in the future, but as long as you kind of build a really good system for collecting really good data, the possibilities are endless as you grow. So let's put it all together, which is Industry 4.0, or the lab of the future kind of concept. So everyone thinks of Industry 4.0 as kind of the computers and robotics, but it really isn't. It's kind of taking computers and robotics and giving them an intelligent layer, meaning they can make decisions. So a quick example is, let's say, a fully automated manufacturing plant that takes into account the humidity and temperatures and maybe final testing in the quality lab to change the mix or change slightly the ingredients that are going in to keep getting really consistent, great output material. That's where you get to Industry 4.0. So what can you do today to kind of start moving in that direction? I think there's two major things that you need to think about. One is increasing automation in labs, because we're talking about labs today. Production is already improving every single day and ramping up. But if you can increase your automation in labs today, that's a huge step forward. And that can be anything. It doesn't have to be what we have. There's other offerings out there that might be more important to you. Maybe hardness is more important. Maybe the rheology data is more important. Whatever is important to you, look at that and see if there's potential to automate. The second thing is improving your data collection. We see pretty kind of sporadic data collection where each system might save into a place. There's still Excel sheets where people are kind of doing very interesting things. There's still papers where people write things on them and then they scan them in. You got to improve all those and really try to digitize and clean up that process as much as possible. Centralize it if possible into a cloud system. I know there's a lot about security when it comes to cloud, but the reason for the cloud system is it really allows you to kind of have that data ready for the future use, whether it's porting it in for other companies to help you out with AI systems or whatever it is. That could be a huge step forward. And lastly, connect as many machines as you can to kind of a very centralized system. I think a lot of companies we walk into are still using kind of systems where each one is on its own, and then they collect the data and they put it in themselves. The faster you can speed up that process and the smoother you can make that process, the better the whole system becomes in terms of Industry 4.0. We think it's kind of a multi-stage process that most customers that we've seen go through that are more successful. So we find that the first step is looking at some form of automation in the labs so that you can start that clean collection data process, along with thinking about a software that you can plug in for that data to go into, whether it's uncountable or clean software, whatever, your own LIMS system that can go cloud-based. It might have a great way of doing it. So that's stage one, and it could be any automation, really. Again, it doesn't have to be just whatever we're creating. It could be, there's other great automation out there from other companies. And if you guys need any suggestions for anything that you do every day that you want to automate, please feel free to reach out. We're kind of connected to a lot of companies that do great other automation. So that's stage one. Stage two is starting to connect everything through, whether through our system or other systems that you already have that you can implement even faster. That's even better. Encrypt, secure the data, but make sure it's all kind of in the same format, clean, digitized. And then stage three is where you start to reap the final rewards, being that you can use AI, you can use machine learning, you can use some form to start better predictions and speed up your process and move towards this concept of a map. Now, we're getting close to the end here. So maps, this is an amazing new concept. It's called a material acceleration platform. And the goal is to combine essentially everything we've talked about to speed up the process of creating materials to a different level. So imagine a lab where it can mix the materials on its own, it can test the materials on its own, puts that data into an AI system, figures out what to mix next, and keeps going until it creates the perfect material. So let's say a customer comes along and wants to change the properties or wants new properties. Or today, sustainability being a big thing that we're all pushing for, we need to create really sustainable rubbers and materials. Well, we got to test a lot of ingredients and we got to test how they combine and the final results a lot to get a really good sustainable material that's also a great material for customers. So you could do that using these fully automated labs. And it might seem like it's very academic, but it really isn't. It has been done out in industry in different places, not as much in rubber, but in other industries. And the results are absolutely amazing. So here's a map example where they did one for light stability. Essentially, it was chosen where they looked at a development that had already occurred in the past, and it took over 1,000 iterations, and it took years of development to create something that they needed and then were able to sell. And what they did is they created a full map to kind of do the same thing, to show the benefits and how much faster it could be using a map system, a fully automated lab versus our conventional methods that we do today. And the results were amazing. It went from years to weeks of development time. And if you can only imagine, anytime your ingredients change, maybe you have the supply chain issues and you have to change an ingredient. Again, maybe the sustainability, you're pushing for brand new sustainable materials. Those companies that jump on this and start utilizing it and start implementing it correctly today will be able to make huge changes and have a huge competitive advantage when it comes to moving to the future. So this is kind of where it all comes together. When you take the automation, when you take the AI, and when you start creating these really amazing smart labs, you can take things to a different level when it comes to both development, but also in the quality and production point of view. I think that's all I got. Thank you so much, everyone. Here are some of our details. If anybody has any questions, would like to reach out. If you want to hear about other systems that we know of, both from the automation or software side, please feel free to reach out. I'd love to give you guys connections as well. Thank you so much.